This is section 4, Factor and HIRA. In this section, we'll look at working with node facts, we'll talk about creating custom facts, we'll talk about configuration with HIRA, automatic class parameters, and how to do HIRA data lookup. Node facts. In this video, we'll talk about factor, we'll talk about the available facts, and we'll look at using those facts in our node manifests. Factor is a program that comes with Puppet, that's installed with Puppet across all of our nodes, and its purpose is to collect facts about each one of those nodes. So Factor will run on the client, will collect all of those available facts, and it will ship them to the server where they can be used in building the catalog. That might include things like what operating system this node is running. Is it Linux? Is it Windows? If it's Linux, what distribution? Is it Red Hat, CentOS, Ubuntu, Debian? For that distribution, what version of that operating system is running? How many processors, how much memory, the available disks, networking, all of that kind of information that might be useful to build the catalog to make decisions about what to install on a node or how to configure it. Let's take a look at how we can see what facts are available. So the Factor program is a separate program, but we can access it using Puppet facts. Now if we do that, we'll get a very long list of facts that will fly by. You can see that it includes a lot of different information. We can also get to the same information by running Factor directly. And if we do that, we should pass -p. That tells Factor that Puppet is also available, and it should look at the Puppet configuration to get a list of additional facts that it can collect. Now, one nice thing about running Factor-P is that we can give it the name of a fact that we'd like to have it return, and it will return just that information. So you can see for this particular machine, it lets us know that this is CentOS 7.5, 64-bit architecture, returns SE Linux information. Similarly, I can look at information on the processors. This particular virtual machine has 2 cores with a single physical host, of course virtual processors. And if I'm interested to know whether or not this is a virtual node, I can ask Factor that information too, and it tells me not only that it is, but also that it's running on VirtualBox. So there's lots of useful information that we can use, collect from Factor, send to the server, and then use in our catalog. Now that we've seen a little bit of what kind of information is available, let's take a moment to talk about exactly how we would use that information in our catalog. There are a few different ways that we can do that. The older way to do it, the way that was current up until Puppet version 3, is to just access these facts as a top-level variable by just using a $sign and then the name of the fact. Now, for older versions of Puppet, it wasn't always clear exactly what variable you would get if you just access them directly like that. So what people would do is use this $:::: notation, which you've seen me use before just as illustration, to show that this is a top-level variable. We want to go back up to the top scope to use this variable. And neither of these are really necessary anymore, and in fact these are not recommended, because the problem with accessing facts in this way is that they can actually be overridden within the catalog. So what we prefer to do instead is to use the second example, which uses a facts hash. So this is a top-level variable called facts. It can't be overridden by the client. It is a hash, which means it's like a dictionary or like a hash map. You give it the name and it returns the value. And if it's a hash that includes a hash, like we saw in that OS example, you can use that same square bracket notation multiple times to delve down into the data structure to get the data that you want. All of our node facts are contained within that top-level facts hash, and that's the recommended way to do it. Now, we said that all of these facts are collected on the client, and that means that really the client is in control of them. But there is one thing that the server can verify the value of. When a client connects to a Puppet server, it passes in a certificate, and the server verifies that certificate. It checks it against the underlying CA cert that it has available to it, the certificate authority. All of the information that was in that cert goes into a separate hash called trusted. So that includes things like the host name, which is the first part of the common name of the certificate, the domain, that kind of information, as well as any SSL extensions that might have been loaded into that certificate. So that information in that trusted hash you can consider as special because it's information that the server has been able to verify, as opposed to regular facts, which is just self-reported by the client. There's one more. If we set a trusted server facts option on our Puppet server, then the Puppet server will also populate a server facts hash. And that just includes a few pieces of information about the server, like its IP address, its host name, what version it's running, just in case that information is needed. So we would really like to access our facts through the facts hash. Now that we have a way to access them, it comes a question of what are some examples of something useful you can do. So I wanted to show you an interesting example of what you can do with facts. This is kind of a neat approach and uses a feature of Puppet that I think is actually pretty useful and worth showing. Within this example environment that I've created, I'm using Vagrant to create multiple virtual machines, and that includes my Puppet server as well as my log server that includes Elasticsearch, Kibana, Logstash. It also includes 2 clients that feed information up to that log server. So all of these virtual machines are created for me by Vagrant. And the way that I do that is I provide Vagrant with this Vagrant file. Now, this Vagrant file includes some information on all of the hosts that I would like Vagrant to create as virtual machines. And Vagrant uses this information to create the hosts and then to configure their networking. Now, within the virtual machines, I would like to have the same information in the etc hosts file so that all of the machines can refer to each other by their names instead of just by IP addresses. It so happens that Puppet has a host resource type that will create entries in etc hosts for me. So that's very useful. That's exactly what I need. However, I don't want to have to repeat this exact same information again in my Puppet code because they could potentially get out of sync. They would be wrong. If I add another host, I have to remember to add it both places. I'd really like to only have to say this once. So what can I do about that? I want to use Puppet to put this information into etc hosts, but I don't want to have to repeat it in my Puppet code. This is a perfect example of what facts can do, and it actually ends up being pretty elegant. So when I configure Vagrant, I tell it that not only do I want it to create virtual machines, I also want it to run Puppet for me. And I tell Puppet I want you to run from the Vagrant environment, and I want you to pass in a fact called hosts. I want you to take this hosts hash that exists up here, this data structure, and convert it to JSON. The reason I convert it to JSON is because Vagrant only supports string-based facts, so I have to pass this in as a string, and JSON is the best way to preserve the structure while also passing it in as a string. So I tell Vagrant, please run Puppet for me on each of these virtual machines as they come up, and use the Vagrant environment. Now what that means is that Puppet will go and it will find the Vagrant environment, it will find the site.pp in the manifests directory, and it will look at that to see what the configuration is. And you can see it ends up being very simple. What it does is pretty sophisticated. I use this create resources. Create resources is a Puppet function that will work through a data structure, and it will apply the specific resource type multiple times, once for every item in the data structure that it finds. So the data structure that we pass it, we start with that facts hash. We use the fact name of hosts, which is the same thing we specified in Vagrant. We use parse JSON to take that JSON string and turn it back into a data structure. And then we take all of that information and we pass it to create resources so that for every one of the items that was listed in that hosts list, Puppet will create a host resource for it, which means an entry in /etc/hosts will be created for each and every one of those items. Now this defaults. This is a separate hash that I create because in my Vagrant file, obviously I don't know anything about ensure present and all those Puppet things, so I pass that in as the secondary parameter so that that gets filled in to each of those data structure host items as we go. So the result of all of that when I boot a virtual machine, Vagrant will automatically run Puppet with the Vagrant environment. It will pass that hosts array through, that hash through, as a JSON string, will be parsed. Puppet will then create a host entry for every one of those things, and as a result, if we go back over to our server, we can see that Etsy hosts includes an entry for every one of the items that were configured in that hosts hash. So this is a neat example of what you can do with facts. You can actually use facts to control passing data into Puppet from the outside, as well as using it to collect data on each node and apply it. That concludes our introduction to facts.